everyone, welcome to another Math 9 video. We're doing 1.3 square roots of non-perfect squares today. So I'm just going to run through some quick examples to give you an idea of how to solve questions that are like this. So we're going to start off first with the square root of 15. So I'm going to start off just sort of approximating. The way that I want you to look at this or approach this is I want to look for the two closest perfect squares to 15. So when I see this, I think, okay, that is almost the same as root 16, and we know 16 is a perfect square. And the smaller closest perfect square would be root 9. And I know that the square root of 9 is equal to the number 3, and the square root of 16 is equal to the number 4. So I look at this and think, okay, I know that my answer, when I go to give my answer here, that it's going to be somewhere in between 3 and 4. So I know it's going to be 3 point something, and I'm going to put a line there to represent the something. To determine which decimal place or what value I should put in here, I look at it and I sort of approximate. I look at it and think 15 is almost, like root 15 is almost at root 16. So it's probably not going to make sense to say this is 3.2, for example. If it had been closer to root 9, I might say it's 3.2. But if it's almost at root 16, I would say maybe around 3.9 would be a good approximation for what this is equal to. And I'm actually going to change the equal sign to make it this squiggly equal to sign, which means approximately equal to. Or the other way that we can do it is an equal sign with a dot on top, means that it's approximately 3.9. Okay, so then let's look at another example of what might be similar. Let's try to find the perfect square of root 40. So what I would want is for you to pause the video and try this on your own using the same approach as we did in the last one. So I'm just going to move this up so you can see it clearly. And when you're ready, you can hit play again and see the results that we go through together. So I'm going to use the same approach as last time. I'm going to look for the two closest perfect squares, the smaller one and the larger one. So I look at this and think, okay, this is just like, or very close to, root 36. And we know the square root of that is the number 6. And the larger perfect square to that would be root 49. And we know the square root of that would be the number 7. So I know that this is approximately equal to 6 point something. Because if this is in between the numbers 6 and 7, I would refer to that on a number line as 6 point something, because I haven't quite reached 7 yet. Okay, and then if I'm looking at what the difference is between these, well, I'm actually going to count them this time. So the difference between 36 and 40 would be like 4 spaces away. And the difference between 40 and 49 would be like 9 spaces away. So this is giving me an idea that this is closer to the number 6 than it is to the number 7. If the difference here and here was exactly the same, I would say 6.5, but it's not. So I'm going to approximate and think, okay, if it's, I would say maybe 6.2 or 6.3, because it's only 4 spaces away from root 36. So if you were to say 6.3, I would say that's right. If you said 6.4, I would say that that would be okay. 6.2 would probably be a better one. If the space here and here were exactly the same distance away, then I would say 6.5. So I'm giving you an idea of the thought process to figure out where this is coming from. Okay. So I think hopefully you've gotten the idea with that. I'm going to ask you a little bit differently. So between what two integers does the irrational number fall? If we have, for example, root 70. Okay, so without me explaining it, you may be able to make sense of this yourselves based on what we just did in the last two examples. So again, you can hit pause and try this on your own. And if you're not okay with that, then just keep watching and we'll go through it together. It's actually quite similar to the last two. I'm still going to take the same approach. So I'm going to look for the two closest perfect squares. If it says between what two integers, just to remind you, that would be two whole numbers, positive or negative, but not any decimals. So I want to know which two numbers this falls between. So the closest perfect square to this that's smaller is root 64. So you're getting a sense here, you really need to know and memorize your perfect squares from this. And the larger one would be root 81. And we know the square root of 64 is 8. And we know the square root of 81 is 9. So I would say between 8 and 9. That would be my answer, and that would be how I would give my answer. Okay, so I hope that that is helping you to understand how to work your way through questions like these. And let's take a look at another one. Let's say I give you something that has to do with the Pythagorean Theorem. Pythagorean Theorem. So just a reminder, I believe this is review, it would be a squared plus b squared equals c squared. And when we have something this important, I put a big box around it, I'm going to put a star beside it. You will need to know this and have this memorized. So if we have the Pythagorean theorem, it always goes with a right angle triangle that looks like this. And to decide what the sides are, well, this side, it doesn't matter if I call it A or B. Same with this side, doesn't matter which one is which. But what does matter is that this side C is the one that's right across from the 90-degree angle box. That is called the hypotenuse. So again, I believe this is review for you. But it's nice to have a little bit of review when it's been a while since you've done something. So then if you are asked to find x and you have a triangle that is given to you that looks like this, we want to take our knowledge of Pythagorean theorem and use that to figure out this missing side here. So let's figure out how to apply this. If I am looking at this, the 4 is like the A. So I'm going to say 4 squared plus the x is like the b down here, so plus x squared equals 5 squared. So this 5 is this, which is like the hypotenuse, just to make it super clear for you. Okay, so then you've gone through BEDMAS, or you learned it last year. We'll review it a little bit and we'll do more of it coming up. But we want to get rid of these exponents first. So 4 squared we know is equal to 16. We can't do anything with the x squared, so we'll leave it as is. And this is equal to 5 squared is 25. Now, you'll hear me repeating this. Algebra is all about opposites. So if we are trying to get rid of the 16, because we're trying to get the x by itself, then I would want to subtract 16 on both sides. And an equation is like a scale. I want to keep things balanced on both sides. So whatever I do to one side, I have to do to the other. So when I look at this, 16 minus 16 is just gone. And x squared is equal to 9. Now I don't want x squared, I want just x. So I'm going to square root both sides. And when I do that, I find that my x value is just equal, sorry, not 9, the square root of 9 is 3. So after all that work, our answer or our solution would be that x is equal to 3. Okay, so let's do another one. We want to find the closest integer, and we have the square root of negative 85. So this is just like what we did in the last few examples, except there's a negative sign out front. So I'm going to leave that off to the side. I'm going to do this, and I'm going to say, I know my answer is going to be negative. So I deal with the root sign without the negative there. So the square root of 85, well, the smallest closest perfect square would be 81. And the largest perfect square would be 100. So I look at it and think, which one is it closer to? And I can see that it's much closer to this one. So the square root of 81 is actually the number 9. So I would say this is approximately equal to negative 9. So that's what I would give as my answer for this. Okay, so your homework for this page, or your assignment for 1.3, is numbers 2 to 11, but I want you to omit or not do 5 and 7. So I hope you found that useful.